So thank you for having me. My name is David Pine. As Tony, our fearless leader here, has suggested, TypeScript's terrible.
No, TypeScript's good. JavaScript's
Yeah, TypeScript. JavaScript, yeah, we're going to get into this. So without further ado, TypeScript, making JavaScript tolerable. If you're on Twitter, I hope that you'll follow me. I tweet a lot about different things like technology, and I lay off politics. I don't do that on there. I also maintain a blog at davidpine.net where I blog about like all sorts of stuff. So check it out. So couldn't start this off without saying thank you to Tony, thank you to all the sponsors that he mentioned, thank you to MK8JS for making this possible. So thank you for coming here, because without you guys in the developer community, I wouldn't have a reason to be here and speak tonight. So thank you. So we're going to start with what. So like, what is TypeScript? But before we do that, we need to dive into JavaScript. And since this is MK8JS, I'm assuming you people are familiar with JavaScript. A little bit, right? I'm sure there's opinions in here about JavaScript. So feel free to throw stuff at me or share your opinions. So JavaScript appeared 23 years ago, right? It's old, it's been around. A lot of people actually don't even know that. So that's kind of enlightening. It's a dynamic, untyped, and interpreted. I like to put interpreted language in there because people ask about that. Does everyone know what that means when you say interpreted, right? So imagine you're a client, or you're just a user and you're on a browser, and you go to a website and you request that website to come down. There's a request. It can travel potentially all the way around the world, right? So you get this text file back, and it's interpreted on the fly, and it runs and compiles and runs and works, and amazing things happen because JavaScript is actually really powerful. So it's kind of neat that that happens. It's actually the world's third most popular programming language. These other two languages, I don't know if you've heard of them. Apparently they're more popular for some ungodly reason. So JavaScript. It was originally prototyped in 10 days by Brandon Eck. So I mean, some people have spoke on JavaScript and they talk about how it was like completely built in 10 days. And it wasn't, it was prototyped in 10 days. So that's one thing I like to kind of do in air quotes, is prototype. Because it wasn't finalized. Brandon and I still had a lot of work to do, and they did, and it's still evolving today. So 23 years ago, a 10-day effort turned into this amazing, powerful language that's used literally all over the world for all sorts of things. But that explains a lot, right? The whole being prototyped in 10 days. So you can think to yourselves about all the funny jokes that you see as it pertains to JavaScript, the language. Perhaps its limitations or little gotchas or things that you're not necessarily familiar with. So one thing I like to point out is JavaScript this, the contextual this. Who has a definition for this? Anyone want to raise their hand and throw it out? I think you're a JavaScript guy. You were ready to raise your hand there for a second. Define this.
I was trying to think about it. I don't know. I don't have a definition for it.
So, yeah?
The current context?
Current context. It's pretty good, yeah. I'll accept that as a valid answer, and as that, you have yourself a sticker. This is basically, it's the context of the scope. So whatever the scope is, right, wherever you are. And a lot of times that can be window, if you're global within your application and you're in the context of a browser, right? So you can do odd things with it. It's not like the standard this, keyword for other languages that are, a little different. We have books on JavaScript, right? So there's stuff, this here is the good parts on the left, and then this is the definitive guide. So as you can see clearly here, there's a lot more of a guide than there is the good parts. But this is by Douglas Crawford, and he's arguably very opinionated, and that's okay, but a lot of times people will laugh about that. At least there's good parts. There are certain languages that don't have any good parts. So we're going to look at some code here. Just real quick, this is briefly just kind of throwing some little interesting things that are kind of gotchas about JavaScript itself. So if we have an array, we define that with undefined null and an empty string. Did you know that that's loosely equivalent to a string with 2 commas in it? Because that makes sense, right? if you don't think about it. If you instantiate two objects, we have this notion of coercion and arithmetic, and there's these different parts to JavaScript, the language, and how you interact with it, and things that you might not necessarily be familiar with, right? So a lot of people are familiar with like the triple equals versus the double equals, and that's something that's not a big deal. But did you know that with arithmetic, if you do object 1 greater than or equal to object 2, that's true, but also the invert of that is true? Yeah, why does that make sense, right? But general equality stuff would make sense. That's fine, that makes sense. Did you know that this is perfectly valid JavaScript? As of ES3, this entire blob right here, and it actually, that const message variable is equivalent to strange thing. That's a string that it just prints out. All these different parentheses and plus marks and bangs and angle brackets. It's like, what is even going on there, right? Who writes their code like this? Does anyone do this? I don't know if there's any other language that actually would interpret something like that complexing and make it a string. So that's kind of interesting. Also arrays, you can do some kind of weird stuff, right? If you just nest arrays, who does nesting of arrays? Who does like this obscene level of nesting of arrays that will still hope that internally coercion works with your string and makes it an int or a number, right? And then does the multiplication on it. Or it's like that feeling that you get when you actually watch Gary Bernhardt's What video. Have you seen this? Like at the end of it where you're watching, he does all these little cool things with JavaScript. And you're like, oh my God, I had no idea that actually does that. It's kind of weird. He ends it with, an array of 10 dot join wat -1 plus the verbatim string Batman, and what do you get? No, Batman.
Is that where you got this stuff from, Gary?
Not all of it. No, just this last bit. Other stuff is, if you want sources for it, I can do that. I'll add that to the comments and the meetup notes. But at the end of the day, it's just JavaScript as a whole. People will call JavaScript like the Wild West, but I like to think of JavaScript as the all-encompassing sun, right? Where if you're in the Wild West, it's hot. And you're like, oh my God, it's a really hot day. I can really feel this kind of weighing on me. I'm sweating a lot. I'm working with these things that I may not be comfortable with. And then it goes away and you're like, wait a second, where did all the JavaScript go? And then it comes back around and hits you again. This is where TypeScript comes in. And TypeScript to me is like the new sheriff. It's the sheriff in town that is the Wild West. And it kind of helps mediate a few things here and there. But it's not this huge monolithic thing where you have to like totally invest wholeheartedly and forget everything that you know about that hot sun that comes back around and beats you up. Okay? So TypeScript, right? So we talked about JavaScript, the history of it, where we've gone, and now for me, I believe that TypeScript is the future. Even though it's not very new, right? So a lot of people hear TypeScript. And I've been talking about TypeScript for years now, and TypeScript isn't really a new thing. It's been around for a while. So October 2012, who knew when TypeScript was born? Who thought it was newer than that? Probably a lot of you. And it's a true superset of JavaScript, right? So any valid JavaScript is actually valid TypeScript, which is kind of cool. Who knows the name Anders Helsberg? Couple? So Anders is the brain trust. He is the one who, his purpose in life is literally to develop languages and design languages. So he's responsible for Turbo, Pascal, and Delphi. And actually, he was the lead architect on C# for many, many years. Microsoft saw him, and they're like, we want you to work for Microsoft. And he's like, well, let's talk about this. And Microsoft said, how about we give you $500,000 as a signing bonus? Like if Microsoft came to you today and said, do you want 500 grand for a signing bonus? You would say, okay. So he went back to Borland, and actually what happened was, Borland's like, we're going to counter. And then Microsoft said, no, he's ours. If he's even considering it, we doubled down. They gave him $1 million as a signing bonus to join Microsoft. And he is the inventor of TypeScript, the language. So this is a quote from Anders. He says, JavaScript was intended for 100 to 1,000 lines of code. Now with regularity, applications are these huge monoliths, right? You know, with SPA frameworks and things like that, JavaScript isn't really what it was prototyped to be from Ben and Ike years and years and years ago, right? Can we agree on that? Who here has like an example of a large application that they're doing in JavaScript? Just throw out a number. Someone throw out a number. Anyone? What's 10,000 lines, 100,000 lines? 5,000 lines? So if it's just JavaScript, right, the larger you have those files becoming in theirs, or this collection of files, it almost goes back to the root of what web was, right? When documents were first introduced, when HTML was first introduced as like this web technology, it was for serving up static documents, right? And then people are like, ooh, we can style these things, right? So they got CSS, and then what if we want to have a button? Someone clicks on it. Let's just sprinkle some JavaScript there, right? And then the thing was, you know, these smaller applications were built out that way, but they started becoming larger and more complex, and then JavaScript became this larger thing. But if you have applications that are written and you have hundreds of thousands of lines of JavaScript, typically those are actually still just documents, right? Because God knows you don't want to touch it. Because if you walk up to that much lines of JavaScript without decent tooling around it, it's going to be a nightmare. So, and that's my opinion. So I'm entitled to that, I think. So TypeScript. TypeScript files have the Atsc file extension, pretty simple. It's backwards compatible all the way to ECMAScript 3. It's any browser, any host, and any OS. Modern, Node.js, VS, Code, all the different tooling, we'll get into that. It's open source. And it supports the latest JavaScript features. So I just like saying that JavaScript, right, knowing where the things we talked about and what, you know, TypeScript likes to introduce with all of its ideas, JavaScript wasn't originally designed to scale. Okay? And only you can prevent JavaScript. So I leave that up to you. You guys are responsible now to not write JavaScript. But yeah, at the end of the day, all your stuff's JavaScript anyways, and we'll show that. So I got a demo. Oops. Let me make this larger. Okay, can everyone see this okay? Back there? Looks good? Not terribly. If you want, I can make it larger, or we can do different contrast. I know this display is a little dark. Do you want me to switch the theme? Yes, no? Feel free to speak up.
I can read it fine.
You can read it fine? Okay. One more. Okay. So here we have a simple JavaScript file, right? Main.js. We got a function, very, very simple. Sort by name, given this parameter A, because we're all developers here. We're very good at naming our stuff, right? So this is A. So we might infer that this means array or something, right? So let's say we've got var, result, A slice, and then we're going to sort on function X and Y, and we're going to do a comparison and return it, right? So we're just doing common sorting stuff, and it's not a big deal. And if we walk up to Visual Studio Code, we can see that A is defined as any, right? So there's no types behind it. It's just anything you want to give it. So we could just say ... And would that be valid? No, probably not. What about an empty object? Sure, why not? What about an array? What about pickles? Anything you put in there is pretty much just going to be valid JavaScript. It's fine. It looks at it and it says, this is, sure, why not? Because there's no types. So we could just invoke it that way too, or we could walk up to it and do other things that are kind of nasty, but we'll leave it alone for now. We'll just say that that's JavaScript in a nutshell. So if we walk over here and we say F2, we're going to just simply change the file extension. Now we're TS, we're TypeScript, right? Now we're TypeScript developers. Yay! So what we're going to do here is let's just say we're going to define an interface, okay? We're going to call it people, and we're going to give it a name, string, and age, number, right? Simple little object, right? Now say we want to define this type here, the argument, right? So this type is, how about it's an array of people, okay? Uh-oh, all these JavaScript developers were sitting here in the room and they didn't see this before, right? We were all looking at this JavaScript, just taking for granted that it was valid. But since we defined our type here as a people array, if we walk down to this sort operation, it knows first of all that X and Y are actually people, right? That's the shape of those objects. Therefore, name must be a string because that's what we defined it, right? We provided this type for it. And it knows, TypeScript knows that it has the entire surface area for the API that exists for JavaScript on all the different ECMAScript standardizations that you choose to target. So with that said, it knows that since name is a string, local compare doesn't exist. How about locale compare, right? So all of us JavaScript developers were sitting here staring at this bug, not knowing that when it ships halfway across around the world and they go to execute it, it would blow up and it would leave a little cute console.log in their browser. And their app wouldn't work, but no one would know why, right? So this is kind of where the preemptive approach of TypeScript comes into play, and how if you apply these little types like this, things can get really interesting and it can become very, very powerful. So let's say we have a type person because we want to get really cute. We want to say people array person equals that. So if we say this is now this, we have this type alias that we just defined. We can export this too. We can do anything that we want. This can be a module. So now down here we have, oh sorry, I did that backwards. This should be a person, that should be people. You guys should call me on that. Yeah, you get the point though. But, so then the other thing is we can do, let's delete this. Who likes using fat arrow? Right? I like that you guys raised your hands that time. You're like, yes, I like this feature that lets me type less, right? I don't have to type function. And we can all appreciate that. And the cool thing about TypeScript is that you can still do that. You can leverage all the latest features of the ECMAScript standardization and still be backwards compatible all the way to ES3, right? So let's just take this a step further. Let's see if I can pull up a console here. I have it. So what we're going to do here is we're going to do TS TypeScript Compile. This is simply an NPM package, from Node, right? We have TSC, which stands for TypeScript Compile, and it's a little utility that can compile our TypeScript. So we're going to say init, and that created a tsconfig.json file. And this has all the stuff in there that we can use to configure it. And it's very, very detailed. There's wonderful documentation around it. It's all open source, so you can go check it out. But what that does is allows us to walk up to that command line and say tsc compile. And what it's going to do is it's going to compile our, it's going to complain to us actually. Because I switch things around. Person, let me fix this real quick. People, person, people, bam. All right, so now if we save, pull it back up, run it again, tsc compile. So now we have a JavaScript file, okay? And if you notice, what's the difference between the initial JavaScript file that we started looking at? Besides the use strict, don't mind that. It's bug-free. It doesn't have that bug in it, right? And we were all sitting there looking at that file for a little bit, that simple 5-line function, and none of us saw it. But because of TypeScript and applying these types, we can start to solve these types of problems, right? Pretty cool. So that's the first demo. Let me make this larger. So to me, TypeScript is like the cure for the common JS, because I thought that was cool to say it that way. So why? Why should you care about TypeScript? What about TypeScript is, what's the why? Right? We saw what it is, we know about JavaScript now, but why? Why should you care? So, is anyone familiar with this logo? A couple of people, yeah. If you're not, that's great too. I don't really care for their website. But these are basically quotes from lead JavaScript developers or engineers on these logos teams that decided these are the reasons behind why they are basically imposing that all of their JavaScript development is now done with TypeScript, right? So they said that Reddit says they must have types and must power major production apps, right? Because Reddit is massive, and it must enable that their devs can get onboarded really, really quickly. Because with typed languages like that, you can rely, as a developer, you can rely on tooling. You can rely on knowing that if you write a line of code, you might, if you don't have a typo or whatever, it's going to work, right? You guys know this one here? I know some people might say React and cough, and it's like, no, that's Angular. But TypeScript makes code easier to read and understand. And this is from the lead engineer behind Angular. They're good at versioning, so I don't know what version I know. Version 6, but from 2 to 6, after AngularJS 1. But Victor says that it's easier to read and understand, and I agree with that. You guys know this one? Slack. This is not Microsoft Teams. This is Slack. It's not HipChat either, which is a good thing. The people at Slack said that they want a smart static type checker that increases their confidence in their code. It catches easily made mistakes, right? That's one of the key things, easily made mistakes. Again, we were just all looking at that little one character away from having it right, but it wasn't right. And they like that there's, when they write code, touching on some of the aforementioned stuff there where it becomes self-documenting, it's more readable. So this is my top 5 reasons. This is personally, I've been developing with TypeScript now for 4 or 5 years. So this is over the years, these are the top 5 things that I look for that get me excited about actually being able to program in TypeScript. So the first one is compatibility. I mentioned this before with some of the demos. So JavaScript is standardized through ECMAScript. I'm hoping you all knew that. So not all browsers, though, support all features of the standardization, right? So what does that mean? So we have this notion of a feature gap. So when you all raised your hands before about the things you're excited about, right? The fat arrow, because that's amazing. Or maybe like spread operators, or all these other cool things with the latest versions of the standardization. You want to be developing as a developer, because I know I do, up here at the front. You want to be using the latest and greatest features. However, the stuff that you're developing may not support it, right? So you have to somehow target, God forbid, ES3, or worry about IE 8 or something, right? So TypeScript solves that problem through its compatibility, right? So you can use these latest features, any of the latest features that are out there, literally the day of, you'll get a TypeScript update and you'll have the latest features. The TypeScript team is literally on the standardization team for ECMAScript now. They are influencing it, they are working together, so all the new things that come out, TypeScript is in sync with it. So as a developer, you can be using the latest and greatest TypeScript stuff and still be backwards compatible all the way to ES3, right? Anyone targeting, like knowingly targeting ES3? No one? What about ES5? A couple people? Yeah. Who would like to not have to worry about what you target? Okay. So tooling, I'm big on tooling. I think tooling does a lot of things for us. It's better than just having like straight up Notepad and just trying to wing it and not having tools that help you, you just kind of guess what you're doing, right? So one of the things that TypeScript got right with Anders, being that this is technically his 4th language that he's developed from the beginning in design, is the language services were like a first-class citizen, meaning that that's what they focused on before they started doing anything else, like the syntax and where they're going with features and how they want the language to evolve. That was all like not even secondary, like just tertiary. And the language services was the pivotal thing that they focused on. And as it relates to that, language services are what power your tools. So right, your IDE. So you get statement completion, you get stuff like enterprise refactoring. I like throwing enterprise in there because it sounds more important than it really is, right? But seriously, huge applications can be developed and refactored with ease because of TypeScript's type system. I was in Indianapolis and I gave this talk a year and a half ago, and I don't know if they're lying or not, but they told me that, when I did that question about how many lines of code did you guys have, I was hoping Milwaukee would have had some higher number. They said 83 million lines of JavaScript, and I said, yeah, that's bullshit. I didn't call them on it. I was like, oh, okay, whatever, I'm going to save that one. But right, you can, with TypeScript and the type system, you can do all these things. Also, you get like an immediate feedback loop, right, from your tooling. So if something's wrong, it lights up red, and you know that in order to go eat lunch, you have to make your IDE happy by typing the right stuff. And it's not just Visual Studio or Visual Studio Code, right? Because of the language services, the tooling is so well that all of these things here are empowered by it. And I've actually heard from plenty of people that there is better support from the language services within other IDEs. So who uses something other than Visual Studio Code or Visual Studio? What do you use?
WebStorm.
WebStorm, great. WebStorm's up there. Is there anything that's not up here that people are like, oh yeah, I wish this was supported in my IDE that no one else uses? Nothing. Okay. Does anyone use Vim? See me later. I don't know how to. I just keep rebooting my machine. I don't know how to get out of it. So number 3 on the list is it's open source, right? So I wore in my GitHub hoodie. Does anyone know, like if I say GitHub or ArctiCAD, am I just a weirdo, or do you guys know what that means, right? Open source. Yeah. Clap, yes. Or is that like a depressing clap? Oh, damn it. Did you hear the story, though, about GitHub? This is a total diversion from the talk. There's a lot of people that were like upset. They're like, oh, GitHub, Microsoft bot. And I'm going to go to GitLab. And then I was in South Carolina 2 weeks ago. I was talking with Scott Hanselman about that. And he's like, yeah, but they're going to GitLab, and GitLab runs on Azure. Yes!
No, it doesn't. They're switching to Google.
Sure, they're switching now, but they're on it now!
No, they've been switching for some time.
Oh. Well, this was 2 weeks ago. Old information, apparently. But I thought it was funny. So open source is amazing because you can learn all the things, right? Who's been a developer for more than open source has been around? Probably, okay, some people, maybe? Okay. Like, wasn't there like this notion of like a black box and you just had no idea? And there's even, third-party stuff that is proprietary and you can't look at it and whatnot now, right? But wouldn't it be nice if, as a developer, you could just open up the box and be like, what's in there? I want to blame this API. Not mine. It's not my fault. It's never my fault, right? But as a developer, it's kind of cool to empower yourself to go look at all this stuff. And then you start learning their patterns. You can inject yourself and become an open source contributor. You can post issues. You can suggest features. You can do all these new and amazing things within an open source type of environment. I think that's very powerful. Number 2, obviously, is the type system, right? Because you get basic types, you get advanced types, you get classes, interfaces, abstract classes, right? You can, who's fearful of object-oriented programming within the context of JavaScript? Is that something that people are scared of? You don't mind? Okay. Whatever works, is that how we roll in Milwaukee, right? If the greens build, if the build's green, we're good, something like that. So then you can do generics, which generics is kind of a foreign concept within the world of JavaScript, but we'll look at that more. We get type assertions, type guards, type aliases, polymorphic this, all these really powerful things, right? So number 1 is obviously compilation, right? Taking TypeScript and having an output that is JavaScript that will then work in a browser it's amazing. And I go back to the immediate feedback loop, where I think this is probably one of the first languages where you're actually happy to see a compilation like fail, right? Because then you know your type system's working, right? You can see, oh my God, it didn't compile, so I have to go fix it. So now that it does work, and then I know that my JavaScript is going to be okay, and you can send it along. So now what? Right now we're going to ship it. Yeah. Oh, one thing I forgot to do was pull up the Wi-Fi. We're getting another demo here. Someone's going to holler the Wi-Fi out to me as I type it here. What's the password back there?
Making stuff.
Is it any capitals?
Nope, one word.
Making stuff. Love it. Watch me not even type that correctly. Okay, actually I think I did a link here. Clever. Okay, so TypeScript has a playground. Who likes playgrounds? Who likes like online REPLs? Who likes being able to go into like a sandbox and type something up? And I enjoy that. I don't know. I like CodePen and what's that?
No setup.
No setup. And you can test like little pieces that you're concerned with rather than having to spin everything up. So TypeScript has that. But one thing that's really cool about this is they actually have the side-by-side. So what that means is when we say stuff like public class, let's just call our class Monkey.js because I have no other name to name it. Actually, that's not going to work. This is a class. So this is the TypeScript here on the left, and this is the resulting JavaScript, right? So that's kind of cool. You can see the side by side. So you can do stuff that gets, it's almost like open source but on steroids because you get the immediate feedback of seeing exactly what the resulting JavaScript is going to be. And it's kind of powerful. So one thing I like to show off is enums because TypeScript supports enums. Now before I type the rest of this out here, this is going to be a pop quiz to see who's, so first of all, raise your hand if you think you're like a legit badass JavaScript developer. Like you're going to throw down with some JavaScript. You know what's up. Anyone? Who? Okay.
All have imposter syndrome. Everyone else.
So who's been developing in JavaScript for more than 5 years? Hands up. More than 5 years? Just one? Oh, Rockin' Cat, get up here. You guys, you can't just sit back there. God, what is... Tony, I'm going to pick on you big time, too. Okay, hold your hand up. Is more than 5, more than 7? More than 8, 9, 10, 11, 12? 12, okay. 8. What about you, Tony?
Somewhere in that 7-ish.
Okay. You guys are both familiar with enums?
Yeah.
Okay. If you were going to implement that in JavaScript, how would you do it?
Type.
Okay.
Now that there's const, it would probably just be constant strings that are globally available or whatever.
Okay. Okay. So here's what they did. Sunday, Monday, Tuesday.
Did you say?
Yeah, enums.
What is that?
An enum is basically,
Oh, enum.
yeah, enum. It's like a map between a numeric value and a string literal, right? You can, and it's like a type though. You can say the enum type dot, and then get the property name, and that's, it's pretty powerful. So what they did with JavaScript, the way they implemented this was, when I first saw it, and that's why it's always part of my demos, because I love showing this off. It's a reverse map, right? So they have this object, which is basically an immediate function that's executed, so you get the class name. And as a result of that, they walk up to it and they say, we're going to use the bracket notation, right? Almost like an indexer with this string verbatim Sunday. And that first member is then assigned to the numeric value 0. But this assignment is actually also a pass-through, right? If you had const x equals something like that, that assignment would actually go to, so x would then be 0 also, right? So then this is another bracket notation, immediate kind of reverse map of the day of the week where you have a property for the string literal Sunday, and then for the bracket notation index, if you will, 0. That is then reverse mapped and then assigned to the string literal Sunday. What just happened, right? It's like, holy cow, how did they think of this? But it's so powerful and it's so useful in enums. Like when I thought about it before I saw it, like how would anyone in the world want to implement this? And I had similar thoughts, right, to the gurus of JavaScript. Thank you, Tony and Rockin' Cat, and I appreciate that. But so TypeScript makes it simple, right? It's just, that's all it is, right? And you can say const day of week, because we just abbreviate everything. That's what we do, right? Day of week, and you walk up to it and you get all the things here. And it even says, you know, look at 0, 2, 1. It's got all the things, and it just works, and it's extremely powerful. But that's the way that you can see that it's implemented on the right there, and that's kind of cool. But it also gets kind of scary, because if you look, they have some different templates here. Let's say we want to work with generics, right? So generics are super, super powerful, and I like talking about generics because as a C# developer, generics are kind of one of the things I really get excited about, I guess. I don't know. It's kind of weird, I guess. I get excited about languages. So imagine that we have a class, greeter of T, and you know, we're given a message that type, basically this is called a type parameter. So whenever we walk up to this class instance, we say new greeter, we're required to give that as the type argument. But it can also be inferred, so we don't even need to put it there. And we just know that greeter, when we say greet, is actually going to return a string, right? And this is all just in the browser, so I encourage you to go out to it. It's typescriptlang.org, and they have a playground, and you can just kind of step through these different things and see how TypeScript makes JavaScript tolerable, so to speak. Okay.
Is there a reason to put that on there though? Like when you deleted it, but is there a reason to
yeah. The reason would be if it can't be inferred,
okay.
or if your team. This is where you know, styling comes into play, like where teams are like, oh, I like it this way or I like it that way. If there's a strong opinion either way, I like being implicit because the language services and the tooling is so powerful that you really don't need it. But if you want, you can get more verbose and have it there. Some people think it's ugly, but... Any other questions? So I like to think of TypeScript of almost being like training wheels for JavaScript. So imagine JavaScript is a bike. And when you're learning to ride a bike, unless you're like in the modern age, like my kids, they have like those striders where they don't even have like the training wheels. So this, you know, this metaphor is lost on them, which is sad. But anyways, when I was younger, I had training wheels. And, you know, it was a common thing, a little tool that was kind of there that was just extra that eventually you could even take off later on, right? But it's up to you, and it's a way to kind of keep steady. So don't think of TypeScript as being this big overbearing thing. So how? We talked about the what, we talked about the why. Now let's talk about how, right? So there's basic types, some of those things we've mentioned. There's interfaces. So one thing that's really, really interesting about interfaces, and I didn't demonstrate this specifically. Well, actually I did, yeah. So with the first demo, if you noticed, we defined an interface, right? That person interface with the name and the age, and it was a very simple little structure, right? When we compiled that, do you remember what the JavaScript looked like? That interface was gone. It was a lie, right? Because in JavaScript, there is no interface, right? So the interface is this magical little thing within TypeScript that kind of powers all these things. It's just, you know, basically it's like a contract to say this is what we're, you know, defining this API as, and this is what it's going to look like, and this is how we expect it to work. And consumers of that can go on their merry way using it that way. And the world's a better place. So obviously you can have implementations of that. And then TypeScript will complain to you if you don't correctly implement it, right? Just like any other grown-up, you know, statically typed modern language. Also, we have bools and strings and numbers and tuples. Does anyone say this is tuple? Couple people? You can leave the room. No. You can have nested types. It rhymes with, okay. Well, couple. Like CO.
Yeah.
Well, okay, well, we knew that. Date, right? And then null or undefined. These are all very, you know, common things. Basic types. A lot of these types actually still do exist, but they're just not really something that your JavaScript is aware of. Enums, we talked about that. And if you want to lose friends, if you want to like never have another developer that's your buddy, they actually introduced never as a type. And this basically indicates to TypeScript that this function will never return, or it will throw. So yeah, it's just a basic type I wanted to show you that that exists. So obviously the file extensions, I've been doing Stack Overflow for probably 2 years now. When I first started Stack Overflow, who's heard of Stack Overflow, by the way? A couple people? Okay. You might have ended up on it once or twice, right? So I set out with a goal to try to answer one question a day. And I failed, like, miserably. Like, it's very hard, because there's lots of really smart people who answer questions a lot more quickly and accurately than I do. But it was really enlightening. I learned a lot from it. And I'm actually out of, like, there's 8.7 million users of Stack Overflow. I'm within the top 3% now for contributions, you know, with answers and reputations. That's kind of cool. Thank you. Thank you. But I asked a question on Stack Overflow, and I was snobby enough to answer my own question because no one did. So I said, like, what's up with all these TypeScript extensions? Like, what do all these things mean, right? So I ended up answering the question just by doing simple research and kind of educating myself. So TypeScript obviously is the TS, and there's a one-to-one mapping to the .dts, and this is basically the type definition, right? So you can walk up to a TypeScript library, and from the TS see that TypeScript compile, you can ask it to output all the type definitions. And there's actually a huge community around that is building out, name some packages, some very common packages, or any package. Like name an NPM library that you use today. Like Lodash, React, anything else, just name some moments, yep. All these things, every single thing that you can name, I guarantee the community has built type definitions around it to support consuming it within the context of TypeScript, right? So those are the type definitions. Basically, it's just like the Surface API layer for the types. Obviously, you know this one. I don't need to say what that is. That's your JavaScript. But .map, some people ask about that. But .map's actually been around for a very long time. Who's heard of CoffeeScript? Yep. So .map was all the way back then, right? Where it basically maps your CoffeeScript file. It has a map file, and that maps over to your JavaScript file. That's the same type of thing here. So what's really cool is Google, being that it's, Angular is all gung-ho about TypeScript, within Google Chrome, if you were to try to debug, F12 going to DevTools, you can actually step through and debug your TypeScript, leveraging map files and stuff like that, right? Even though under the hood it's actually JavaScript, which is kind of cool. So we have some more demos. We're going to look at some different types here. Can everyone see this okay? So this is where we get into generics and funky looking code and some of the advanced features, so to speak. So imagine that we have intersections. So intersections are basically a conglomerate of two different types. So imagine you have two things that you're trying to achieve and you want to kind of morph those objects together. You can do so. Right? Imagine that we just define an extend function, which is generic, and it takes two type parameters, t and u. So the first is of type t, and the second is of type u, and the return is defined as t and u. Right? So that's basically saying this is an intersection. Whatever we give this thing, it's going to morph those two things together, and they're going to be available as one object. Right? And all it's doing is simple mapping of members over on top of each other. So it's really, really simple, nothing magical. Right, so imagine we've got a person class with a constructor for a name. We have this interface, it's loggable. We're going to log a message, hooray, void, it doesn't do anything. We have a class, a console logger, which is an implementation of that loggable, and it simply does nothing. It just does a no-op, right? So imagine that we want to extend it, or we're going to invoke that function, that generic function here. If we hover over it, The language services is empowering Visual Studio Code to say, the first type parameter T is a person, and the second one is a console logger, right? And the return, while I named it David, is actually an intersection of those two types. So if I walk up to David and I say, what's available, you get statement completion that's going to tell you all the things that were defined within those type contracts, right? Which is pretty powerful. Likewise, we have union types. So union types get pretty interesting. There's some code we can look at where it says, pad left, given a value of string, we've got a padding here of type any. So if you notice when I said we have all these basic types, I explicitly left out the type any. Because if you're using any as a type, welcome back to JavaScript, right? Who knows what it is? It could be anything. So we could do type assertions. We could say type of padding equals this number string. If it's that, then in this context, right, you actually get flow analysis. So this line right here, this if type of padding equals number, in this context, padding is no longer, if you hover up here, it's an any. Down here, it's a number. Down here, it's still an any. Down here, it's actually a string. You see that? See how you get flow analysis? Like, you can't even do that in C# today, right? C# is probably one of the most powerful programming languages in the world, but it's still confined to definite assignment for flow analysis. So when Anders left architecting C#, that was one of his dreams, was to get flow analysis like TypeScript has. Something for JavaScript, like, oh my God, this is crazy. How are we doing this? So we can say pad left, here's your string, give it a 4, right? This will return a simple function, yeah, whatever. Pad left, give it this. Well, now we can say true, right? And this looks like valid TypeScript, and it is, because the type is any. So where it's actually going to end up throwing this error at runtime. We don't want that. So what we can do is make a union of those two types. If we only want our function to handle two types, the string and the number, the things that we were safeguarding and checking against, we can say type alias string or number is equal to a string or a number. And then that's the type that we define for our parameter on that function. And now, true gives you an error, right? Your tooling is literally yelling at you, that's not correct. Don't do that, right? It's pretty powerful. It's amazing that you can do that. We could take it further with, people like to talk about duck typing and how you can do all these crazy things. I just wrote a blog post about this literally yesterday, how there's this fundamental flaw within the Angular API for their HTTP client. And they're just ignoring it right now because it works. But so, right, we have an interface here for a bird, and birds can fly and they can lay eggs. We have an interface for a fish. Fish can swim, but they also lay eggs, right? So that's kind of like a discriminant, right? Both things are laying eggs. So imagine that we have a function that says get small pet, and it returns the union of those two things. Obviously, I'm just going to say null here so I don't get a compilation error. But if I invoke that, the language services tells me that this instance of this pet is either a fish or a bird, right? Pretty powerful. So I can lay eggs regardless, because we know regardless of those two types, they both lay eggs, so that's valid. But can my pet instance swim? No. And TypeScript's going to tell you why, right? Because it doesn't know for sure if swim is it's non-existent on bird, but it is on fish, right? So you can do, I'm not going to uncomment this out because we got a little bit more to look through. But you can do type assertions, and you can have various user-defined type assertions where you check to see if those exist. And then your flow analysis works the way you'd expect, right? So we're saying function is bird pet given that union type, returning whether or not the pet is a bird. And we typecast it over to fly to make sure that it's not undefined. And if that's the case, this function will prove to us without, beyond a reasonable doubt, that pet instance is for sure a bird. So if we say pet in this context, still a union type, down here, it is definitely a bird. And that is the only option that is available to us within this context, is the API surface layer for that bird that was defined. Likewise, within this else clause, again, flow analysis, down here, we can't fly, but we can swim. Right? It's pretty cool. Type guards, again, with type assertions, type guards are pretty cool. So we can say like is number, is string, and you can get a little bit more elaborate with how you check those, or you can do them inline. Again, that's a style decision, however you want to do that. That's not as exciting, so we'll skip that. Get to some more exciting stuff. Okay, type aliases, we touched on this before, but I think it's pretty powerful to talk about how functions within JavaScript, right? We need to embrace JavaScript because it's an amazing, powerful language that we can play on top of. But functions are a first-class citizen, right? Functions have always been a major part of JavaScript, and so when we define them this way, we can say like type name equals stream, or this type alias name resolver is actually equal to a function that promises to return a string. And promises is probably a bad term to use because promise, right? But then we have a union type here, name or resolver, which is either of those two things. And then if we pass it in, we can actually do a type guard on n to see if it is a string. And if it is, down here, it's already a string. So we just return it, right? Because we're returning a string here. Else, we can invoke it because we know that it's a function, right? Pretty cool. So like interfaces, aliases can be generic. Again, if you like using T, or if you're like writing kind of lower level, like, you know, like perhaps a list or some sort of wrapper around arrays to make access easier, or maybe like a Fluent API around that if you want to get into functional programming. Very, very simple to do with generics and whatnot. So we can define a container with a type of T, where that is basically a type alias for a value which has a generic type of T, or a tree, or a linked list, right? You can implement linked lists if that's what you like doing. Because who doesn't like walking up to an instance of a linked list and saying .next, .next, .next? You don't? I don't either.
No. Why are there dots when they're supposed to be spaces on some of those?
Oh, that's actually just a style.
That's kind of confusing.
It just shows, yeah, I'm sorry, that just shows the white space. That I have that, that's like a part of the theme setting. I'm hitting spacebar here, spacebar, spacebar, spacebar. That shows white space. That lets me know if there's white space on the right side of stuff. I can change the theme if you want.
Is that part of TypeScript?
No, that's just part of Visual Studio Code.
Oh,
that's just a color theme thing.
Oh, it's part of the ECMAScript.
Yeah, actually, I think there's actually a setting for it that's like show dots or whatever, so sorry about that. So string literals, you can do some amazing things with string literals. Who uses strings for logic ever? All the time?
Not all the time.
But yeah, enough, right? It's probably a common occurrence where you're checking the value of a string. So imagine that we have a type we define as easing. We can say ease in, or ease out, or ease in and out. And we have a UI element. We're going to animate. And we're going to have this parameter here of easing. And we can do switch statements on it. Right? Full-blown switch statements that says easing is this case. You could always do switch statements on string literals, right? But not to the extent of the IDE complaining to you that something isn't actually valid, right? It's not actually defined within that. If I could type, that would be great, right? So if we hover over this, type AS, F, F, whatever I type there, is not comparable to the type of easing, right? So it's actually checking against that type, that union type of those string literals and saying this is not a valid case, which is kind of cool. Taking it a step further within this, outside of the switch statement, for things that are actually consuming that API, if we pass in something else, right? Like, I love beer. While I do love beer, it's not actually a valid argument here in this case, and typically it's never a valid argument to say that. But, so discriminated union. Who's heard of the notion of programming languages introducing discriminated union as a feature set, a feature capability of a language? A little bit? Discriminated union is like this pretty elaborate scheme, but we'll go into it here, and hopefully it makes a lot more sense and it's pretty simple. So imagine that we have an interface for a square, and we have kind. And we're going to define it as a string literal. We have size, and then we have a rectangle with rectangle for its kind. We have height and width, because those are unique to a rectangle. We have another interface, circle, and its kind is obviously the string verbatim circle. And then circles have radiuses, right? But they might not have the other things that we care about. So if we have a type shape, so a type alias that is equal to the union of these three things, we can have a discriminated union on the one thing that was common betwixt all of them, which is the kind. So if we say area dot kind, we can switch on that discriminated union because we know that shape, out of all the shapes we have defined here, all of them have the property dot kind. And that kind is a string, and that is available to us to use that string literal magic that we just looked at before. So if we put anything else in here, right, and then you get flow analysis too, right? So when it's a case for a square, S is only a square. Like if however S here, it's a shape, right? At this point, it's a shape. Down here, it's only a square because of that string check, right? Down here, it's only a rectangle because of that single switch, case label, right? Like this is incredible. So case something else. Again, the language services is going to yell at you and say that this is not valid, right? Pretty powerful stuff. So this is basically a safety net for using string checks and knowing that it's going to work.
Can you go back and show the definition of kind again?
Yes. Yes, kind is, again, it's just a string that is defined. Well, since these are interfaces, right, we're actually defining a value for those. Right? So those are the discriminant. That's the thing that's going to discriminate these various things within our union context. So they're just verbatim strings. Cool? So those were some of the advanced types. And that's just like the tip of the iceberg. You can do a lot more with it than just that. And it gets very, very powerful. So we talk about adoption, like who is actually trying to use it. Again, it's been around since 2012. And what's the year? 2018, 6 years. So 6 years, it's been around for a long time. Who's actually using TypeScript today? A couple people, right? So back in 2015 on the far left, this is actual numbers from NPM. This is the stats in terms of downloads per month for TypeScript. So less than, I was just pointing on my screen with the pointer, and I just realized how dumb that was. Over here, thank you for laughing. Like less than 100,000 downloads a month back in 2015. This, I did it at a bad time because it was prior to the end of the month in May. But these are in the tens of millions of downloads per month for this package, right, for TypeScript. So everyone's using it. And with that, I'll stick around for questions, but thank you so much for coming. Thank you for listening to me talk about TypeScript. Hopefully you can start leveraging it, and if you have any questions about that, I'd love to help out. Thanks.